So with these problems, we're taking the math or the numbers that we might be able to know and think about with gases and try to understand what they mean and explain them in terms of the particles and the particles' motion. So if you are asked about the particles in this way, it's very important that you're focusing on what the properties mean, not just stating, well, when one goes up, the other goes up, or it's hotter, therefore I know the pressure is higher. So here, the things that are the same is the same size container, the same pressure, and the same volume. So in terms of number of particles, we know that they're the same. An equal number of particles would occupy the same volume at that same pressure and temperature. Even without calling that Avogadro's law, we could know that, well, if they're moving at the same speed and colliding the same amount in the same size thing, we have to have the same number of particles. But the speed of those particles has to be different. This is a very common free response type of a question. And when you're doing this, it's important not to just say, well, one is lighter than the other. We have to first define at the same temperature, we know we have the same average kinetic energy. And kinetic energy depends on both mass and speed. You can't just say the light ones are fast, the heavy ones are slow, without acknowledging that it's the relationship with kinetic energy and temperature that allows us to know that. So because the temperature and kinetic energy depend on both of those, a different mass, that's an atomic mass or a molar mass, just the mass from the periodic table, would have different speeds. And in this case, it doesn't ask which one's higher or lower, but because helium has less mass, it has to have a higher velocity. Argon with more mass has to have a lower velocity. In terms of mass, we have already defined that because it's the same size container at the same temperature and pressure, it's the same number of particles, but the same number of particles can have different masses. Helium has fewer protons, neutrons, and electrons per atom than argon does. In terms of average kinetic energy, it is the same. Same temperature is defined as same average kinetic energy. No explanation beyond that is needed. With density, we've already defined same volume but different masses. So a heavier thing in the same volume would have a larger density. And then force of collisions is the, or average force of collisions, maybe more properly, is the pressure. Since they have the same pressure, they would have that same average force of collisions. No matter our samples, no matter our temperature, no matter different pressures or the same pressure, there would be some collisions that are high and low in energy or force compared to another, but on average, they would be the same, and that's what pressure is a measure of. When we then connect that here to a graphical representation, so we can think about this at the particulate level, we could draw what the particles are doing, we could graph our macroscopic properties of pressure, temperature, volume, or amount. And then we can also explain that in terms of why the particles are doing what they're doing, or even connect this with some math here. So as we go from room temperature, that's some arbitrary temperature here, that we could have lower temperatures that would then extrapolate down to zero. But it's not possible to have zero temperature. And for most gases, once you get cool enough, they actually liquefy. So the graph doesn't follow a perfect line down there. But if it's an ideal gas, which we'll talk about ideal versus not ideal in upcoming videos, we would treat it as if it is a straight line from the lowest to the highest temperatures. But then we're going up to a much higher temperature here, so we would see the pressure go up. So the particles are moving faster. With KMT, you can't just say it's a direct relationship. You can't just say as one goes up, the other goes up. You can't just plug in numbers. It has to be a particulate explanation. So the faster motion of the particles make them collide more frequently and make them collide with more energy. That is two reasons. This has showed up on AP questions in the past where it asks for two reasons, and people talk about the speed of the particles and then put both of those as one and then go off on some other explanation that's actually incorrect, that's negating one of the points that they could get. We need to recognize that more frequent collisions causes more pressure because that's more force per unit area over a certain time, and more energetic collisions would also be that. So both of those result in a higher pressure.